Hello everyone. So let's now solve practice and week 11 question number 10. Consider the following function f of x comma y comma z is equal to x square y square plus xz square. Which of the following options are true? So the options are asked to check for the critical point for the function f. For that, let's first find the partial derivative of the function f. So first with respect to x it would be 2xy square plus z square. With respect to y it would be 2x square y. With respect to z, it would be 2xz. So these are the partial derivative. Now we know at the point of critical points, all the partial derivative value would come out to be 0. So let's check the option one by one. Option 1, 0, y, 0, where y can be any real number. If we try checking for the fx, that is x value and z values are 0. So if x value is 0, this term would be 0. And as z value is also 0, this would be 0. So 0 plus 0 is 0. So it is 0. For f5, because x value is 0, so this term would also be 0. So it is okay. And for fz, as x and z both are 0, so anyway this would be 0. So it's all on all these points, all the three partial derivatives are 0. So this can serve as the critical point. Now option 2, 0, 0, z. Let's check. X and y values are 0, so this term would be 0. But as z value can be anything according to this, so this partial derivative can be non-zero also. So that's why it will not be the critical point. For the third, only z is 0 and x is 1. So again, as x is 1 and y can be any real number, so this term can be non-zero. So this cannot also serve as the critical point. Fourth, x is 0, y can be anything, and z is 1. So x is 0, so this term would be 0, but z is 1, so again fx would not be equal to 0. So this is incorrect. Now last, x can be any real number, y and z are 0. So for the fx, if y is 0, so this term would be 0. And as z is also 0, so it is 0. So 0 plus 0 is 0. So fx is 0. For f5, as y is 0, so this would become 0. And for fz, as z is 0 here, so this would be 0. So all the three are becoming 0. So this is also the critical point. Thank you.